Here is the shell file for the CDO problem. And we start with data that's available from Fitch ratings. So this is input. Yeah. So for each level of ratings, you have a corresponding probability of default. So any security that has a default rate of whatever, these numbers, and from that we can look at what the corresponding rating will be. Okay, so this is the probability or annualized default rate, and these are the corresponding ratings. So we're going to assume that there are two assets that we're going to bundle together, and let's start with the default rate being BB minus. So that is just about junk bond rating. So this is fairly risky. Have the same rating for the two underlying assets. Okay, so this is the probability of failure. Okay, so we're going to use risk-Bernoulli process, right? With that as the probability of success. So this will give us whether the security defaulted or not. Okay, and we use the same here. So if you go and click that, so that will give you whether it defaulted or not. Okay, now we're going to, that's our input variable, so it's going to simulate that. Then if we find the average of that, so if you did a risk mean, right, of that, so it's going to be, Bernoulli process is going to generate a lot of zeros and ones, okay, from that as the probability of success. So when you now compute the average of that, that's going to give us how many ones are there relative to the total number of trials. So which means it's going to give us the probability of default that we have simulated. So this is going to give us probability of default. Now we can use this probability of default with this table and figure out what the rating will be for our simulated case. Okay, so which should come out to be the same as what we started out with, because we're not using any interrelationship with any of that. We are looking at the two assets independently. So if you did VLOOKUP, okay, so lookup value is this probability, that is the average of default or not default, right? And then we'll do an F4, so we'll be able to copy this over here. And then we have to indicate the column from which the rating should be read, which is 2. And then we have to select whether approximate match is okay or you need exact match. Of course, we're not going to need an exact match, because exact match may never happen. So we want to look at the closest that we get to. So that will be true. Okay. Of course, we have not done any simulation, so it's going to take 0 and then say, all right, the rating is AAA, but that's not the case. When we simulate, this will change. Okay. So now we set up the probabilities for the tranches. So junior tranche would mean what? If either one defaults, right? So we have these two defaults, right? So if that plus that, okay, So if it is greater than or equal to 1, okay, so that means either one is defaulted. So then the tranche itself defaults. Otherwise, it is 0. Now the senior, on the other hand, is that plus that is equal to 2. So both must be 1. Then only it will default. Otherwise, it will be 0. Okay, now these are the outputs. So we got output, and that's also an output. Okay, then risk mean will give you risk mean of that, because that's going to have a bunch of zeros and ones, and the mean will give us the probability of default, and same here. And then we can look at, with the VLOOKUP, we can say, okay, all right, what is the, okay, with that as the lookup probability, we can see what the rating will be. So press F4, and then the second column, and then true. Okay, so that should be true. Is that what we got here? Oh, it didn't come out to be true there. So true, and copy that, and then this again is, we have the true, and then copy that. Okay, so now if you simulate, we can find out, okay, what would be the individual ratings would be the same as what we started out with, which is BB minus. But then when we put them into tranches, okay, what will be the rating of the tranches, junior and the senior tranches, for this case? Okay, so we'll now simulate this, and then we will set up the case where case 2, where the default of the two assets are not assumed to be independent, but they are correlated, non-linear correlation, so which means we'll be using coupler. All right, let's simulate this model. Settings, so automatic. So set seed to 1. Okay. Remember, good practice in real situation is to choose random, choose an initial seed randomly. The only reason why we are choosing fixed is, in an academic setting, we want to see whether we reproduce the same results or not, or whether there is any mistake in the model. That's the reason why we are choosing a fixed seed. Okay, so we're going to simulate 10,000 times. Simulate. Okay. So now you see that when you take the assets individually, it comes out to be the same as what we started out with, which is what we expect. Now, if you see the case where you put the two assets together into tranches and sell them as junior tranche, the rating, if you do the analysis that these two assets behave independently, so you go from BB minus to B. Okay, in the case of junior tranche. But in the case of senior tranche, you see, you go from BB to AAA. So that's That's really a jump. The senior tranche ends up being perceived as a lot more safe bet than the underlying individual assets.